Yes, if there are no other questions, I would like to introduce our next presenter, Mr. James SORENSEN. He is at the University of North Dakota. He is the Director of Subsurface Research and Development at EARC, where he's responsible for developing and managing program and project focused on conventional and unconventional enhanced oil and gas recovery production and geological storage of CO2, geothermal, and other energy and environment research. His primary areas are an interest and expertise are enhanced oil recovery in unconventional tight and oil formations, CO2 utilization and storage in geological formation and tight and oil resource assessment and development. In 2017, Mr. SORENSEN served as the co-chair for the Society of Petroleum Engineers Forum on Enhanced Oil Recovery in Unconventional Reservoirs. And he's been directing many different projects in various parts in the area of CO2 sequestration and also working in unconventional reservoirs. With that, I would like to hand it to Mr. SORENSEN for his presentation. I believe you are muted, Jim.
Okay. Can you hear me now?
Yes, thank you.
Great. And thank you for that introduction, and thank you for inviting me to be part of this workshop. Let me get my screen shared here.
Good.
Can you see my presentation?
Yes.
Okay,
Yes, sir.
great. It says deploying CCS.
Yes.
All right, excellent. Let me get going here then. Well, okay, so thank you. Thanks for letting me be part of this workshop. I'm going to be talking today about deploying CCS, stepping through some case studies from permitted CO2 storage projects in the United States, specifically in the Williston Basin area. There we go. So a presentation outline. I'll be talking about the Plains CO2 reduction or PCOR partnership that formed the foundation for a lot of the commercial CCS projects I'll be talking about today. These formed a foundation in terms of information that allowed stakeholders to move forward with their projects. I'll also talk about the geologic setting of the Williston Basin, some of the economic incentives and regulations that have come into play as these projects have evolved. And then I'll step through sort of a high level overview of some of the projects that we've been involved with at the ERC in the Williston Basin, including the Aquastore project, Project Tundra, Red Trail Energy, and the Great Plains CO2 sequestration project. So I'm going to start with discussing a little bit about what we call the PCOR partnership. PCOR stands for Plains CO2 Reduction Partnership. The PCOR partnership is one of 7 regional carbon sequestration partnerships that were established by the U.S. Department of Energy in 2003. Currently, there are, I believe there are 4 regional carbon sequestration partnerships still going on with DOE funding. The PCOR partnership is addressing regional capture, transport, use, and storage challenges. Really, the whole purpose of the PCOR partnership is to facilitate and accelerate the commercial deployment of CCS, really CCUS, throughout our region. And our region, as you see on that map to the right there, our region includes 10 US states and 4 Canadian provinces. When we originally did the proposal back in 2003, we realized that CO2 doesn't stop at the border. the DOE allowed us to define our own region. And at that time, there was actually a commercial CCUS project going on that was taking CO2 from North Dakota from the Dakota coal gasification plant in central North Dakota and shipping that CO2 to Saskatchewan for enhanced oil recovery. So it made sense for us to try to bring in some Canadian partners as well. So it's a truly international partnership. The goal of the program, the PCOR partnership, is to strengthen the technical foundations for geologic CO2 storage and enhanced oil recovery, to advance capture technology, to improve the application of monitoring technologies, some of which was mentioned in the previous talk. We want to promote integration between capture, transportation, use, and storage industries. We also want to use this information that we generate and bringing these people together for meetings to facilitate regulatory frameworks in the states and provinces in our region. We want to provide scientific support to the policymakers, both nationally and regionally. And then we ultimately want to really enable and advance the deployment of CCS at a commercial scale. Now, the PCOR partnership, the lifeblood of it is genuinely the partners that make up the partnership. We have over 120 active partners representing everyone from industry. We've got the electric utilities. We've got oil and gas companies that might use CO2 for enhanced oil recovery. We've got NGOs representing the environmental side of the equation. And we've got representation from state agencies in all the states and provinces in our region, as well as then relationships with folks at the Canadian federal government, Natural Resources Canada, Environment Canada, and then of course DOE is a major sponsor. And then the Energy and Environmental Research Center, where I'm a director of subsurface R&D, we are the primary contractor that manages and oversees the PCOR partnership. We work closely, other subcontractors that we have in this program include the University of Wyoming School of Energy Resources and the University of Alaska Fairbanks, their Institute of Northern Engineering. So the PCOR partnership has an awful lot of active and developing CCUS projects going on. Everything from project the Quest project up in central Alberta, all the way down to some ethanol capture projects that are going on that are in development in Iowa and Nebraska, and then of course active CO2 EOR projects in the Williston Basin and Wyoming areas. And I'm going to focus in more on the Williston Basin. For those who aren't familiar with the Williston Basin, it's a deep sedimentary basin that straddles the United States and Canadian border, includes the states of North Dakota, South Dakota, and Montana in the US, and then portions of Saskatchewan and Manitoba in Canada. There are a number of coal-fired power generation plants in this region. There's a tremendous amount of oil and gas production that goes all the way back to the 1930s. There's processing plants, refineries, and then there's a number of ethanol production plants. All of these have something to do, have some component with respect to the CCUS industry. Also talking a little bit about enhanced oil recovery, just to really talk about the utilization side of CCUS in our region. This is a map showing the Williston Basin, but also the Powder River Basin. The reason why I include the Powder River Basin of Wyoming in this map is a lot of CO2 being captured at gas processing plants in Wyoming is actually being piped to the Williston Basin, to the southwest portion of the Williston Basin. So we've got conventional and unconventional reservoirs. We've got stacked horizons with oil production. We've got residual oil zones that may be ripe for CO2 enhanced recovery as well. A number of abundant CO2 sources. We've got a CO2 transportation network. That dotted line that actually goes from the Green Corps area, from Bell Creek. This has actually been completed now, and in fact, there is CO2 injection going on in the North Dakota portion of the Cedar Creek anticline for enhanced oil recovery. And then this line I mentioned, the DGC line, is existing and taking CO2 up to Weyburn in Saskatchewan. When we talk about saline storage opportunities in the Williston Basin, we've got a number of targets. This is a cross section, sort of a cartoon cross section of the Williston Basin in North Dakota. And what we've got here are what's notable is the Fox Hills Formation. This is a lower Cretaceous age formation. This actually serves as the lowermost source of underground drinking water. And so that needs to be protected according to EPA regulations. We've got this thick package of Cretaceous age shales that serve as a primary seal to protect the migration of CO2 into the Fox Hills. Below that, we've got the Indian Kara Formation, which in some portions of North Dakota is used for produced water disposal, and may be a target for CO2 storage in the future. The big one that we're looking at in North Dakota that's actually currently taking CO2 for saline storage is the Broom Creek Formation. I'll talk about that a little bit later. And then down here, the Deadwood Formation is where CO2 is being stored in a deep saline formation as part of the Aquastore project with CO2 coming off the Boundary Dam. I'll talk about that in a little more detail as well. In terms of enhanced oil recovery targets, this is a strat column for the North Dakota portion of the Williston Basin. And in addition to the saline formations that I mentioned, we've got numerous conventional reservoirs in the Madison group, which includes the Mission Canyon and Lodgepole formations. We've got the Bakken and Three Forks unconventional reservoirs, which are the biggest oil producers right now in the Williston Basin. We've got a number of reservoirs in the Dupro Formation. And by the way, the Madison and the Dupro and the Red River groups are all carbonate formations. And those all have conventional reservoirs that have been identified as being potential targets for CCUS. So getting into kind of what drives the incentives for doing CCUS in the Williston Basin. Well, the future of the Williston Basin economy is clearly tied to CCUS. Those coal-fired power plants, they provide reliable, affordable energy to well over a couple million people in the region. And shutting those down will have an impact on the energy grid, but it'll also have the impact on the folks that work in the mines, that work in the power plants. You've got a lot of workers and communities that will be impacted if those coal-fired power plants are shut down. You've also got those EOR opportunities that I mentioned. At Weyburn, Whitecap is actually seeking more CO2. They've got a lot of oil that they can still recover with CO2. So they're looking for more CO2. And then one of the biggest things that happened in the last couple of years is the governor of North Dakota, Governor Doug Burgum, announced in 2021 the intention for North Dakota to be carbon neutral by 2030. And Governor Burgum and the legislature have really put in place a lot of incentives to really help make that happen. And of course, CCS is a huge part of that. So some of the economic incentives that we have in the US, the big ones are the US federal 45Q tax credits. Those tax credits include $60 a ton for CO2 stored in a qualified enhanced oil recovery project. And that can be $130 a ton for CO2 that's captured as a result of direct air capture. If you've got CO2 from direct air capture unit going to a qualified EOR project, you can get $130 a ton. In terms of saline storage, saline formation storage, the US federal 45Q tax credit is worth $85 a ton. And if that CO2 comes from a direct air capture, you can get $180 a ton tax credit. So there's significant tax credit incentives for CCS in the United States. There are also established low carbon fuel standards markets. The graphic here shows the values for the West Coast market. This is basically in particular, the California market. This is the California Air Resources Board carbon credits. which are trading. They were trading for as high as $218 a ton in February 2020. They are currently trading, or most recently in September, they were trading for about $84 a ton. And you can stack those credit values with your 45Q tax credits. So you can see there's a fairly significant environmental incentive to do CCUS in the United States. So kind of focusing in a little bit on North Dakota, we've really seen a wave of CCS projects pop up in the last couple of years. This is a graphic from a poster that we presented recently. This shows some of the projects that EERC has been involved in here in North Dakota. These projects include CO2 sources from ethanol, coal-fired power, gasification, fertilizer production, natural gas processing, and other industrial sources. We're looking at matching sources and sinks. One of the concepts that we're talking about in North Dakota is aggregating the source and storage hubs, developing capture hubs with distributed storage, and also looking at hybrid storage with enhanced store recovery, minerals recovery, and other forms of utilization. Now, CCS in the United States in a deep saline formation is going to require an underground injection control permit, a UIC, and specifically a Class 6 well permit. In 2018, the U.S. Environmental Protection Agency approved North Dakota's application for Class 6 primacy, meaning that if someone wants to do a CCS project in North Dakota, they don't have to go through the EPA for the entire process. They can get the permit from the North Dakota Industrial Commission, Department of Mineral Resources. So that's the regulatory authority for Class 6 wells. The other thing in North Dakota that's part of the primacy is that North Dakota has in place rules for pore space ownership and amalgamation of that pore space for the purposes of CCS. So there's a fairly straightforward regulatory framework for doing CCS in North Dakota. That regulatory framework includes pore space access, geologic exhibits, information with respect to your area of review or AOR. It includes supporting plans such as an emergency and remedial response plan for every project, financial assurance and demonstration plan, a worker safety plan, testing and monitoring plan, well casing and cementing program, a plugging plan, and then a post-injection site and facility closure plan. And then, of course, information on the injection well and storage reservoir. So all of that will go into a UIC Class 6 permit application. And then once approved, all of that information will be in the permit, which is then available to the public. Just getting a little bit into the weeds on the geologic characterization side of the Class 6 UIC project. You've got to go through the reservoir characterization and modeling and simulation exercises to determine your simulated boundary at the end of injection. That simulated boundary is then going to be used to inform your simulated boundary after post-injection stabilization. So further modeling and simulation to determine that. And then once you've got those boundaries, then you can establish your boundary and buffer for your storage facility area. And then you've got which in this case, you've got the black outline shows your storage facility area that will be permitted. That'll be the boundary of your permit. You do have a hearing notification area that extends another half mile out from that. What that means is that everybody that lives or owns land within a half mile of the storage facility boundary, and of course everyone within the storage facility area, they will all be notified about the hearings that will be held at the North Dakota Industrial Commission, Department of Mineral Resources to consider the application for a permit. The area of review is calculated based on the simulation. It's typically it's within the it'll be within the hearing notification area, and then the evaluation area. The state of North Dakota requires your model to extend out to an area 1 mile from the storage facility boundary. So kind of stepping through some of the Williston Basin CCUS projects that we have going on that are really in various stages of development or operation. We've got the Great Plains Synfuels plant, which has been capturing a significant portion of CO2 and sending up to Weyburn for enhanced oil recovery. We've got, I'll be talking about the Project TUNDRA project. I'll spend quite a bit of time on the Red Trail Energy project, and then touch a bit on the another CCS project at DGC. I also want to mention that an announced project that's going on, which would be the biggest of all these projects if it comes to fruition, is Summit Carbon Solutions, which is an organization that will be capturing CO2 from ethanol plants in Iowa, Minnesota, North Dakota, and South Dakota, and bringing that CO2 via pipeline to Western North Dakota for storage in deep saline formations. They're looking at anywhere from 10 to 12 million tons per year of CO2 that would be stored in this area of North Dakota here. So kind of stepping through the projects, I'll start with the Aquastore project and the Weyburn project. This is CO2 that's being sourced from SASKPOWER'S 115 megawatt Boundary Dam coal-fired power plant near Estevan, Saskatchewan, in southern Saskatchewan. They've been capturing, they have captured over 4 million tons since 2014. The majority of the CO2 is sold to the operator at the Weyburn oil field. The Weyburn oil field does continue to get CO2 from the DGC plant in North Dakota. A portion of the CO2 from that Boundary Dam unit is injected at the Aquastore location for dedicated deep saline storage. And speaking of the Aquastore project, this is a dedicated storage of CO2 from that Boundary Dam plant that is managed by the Petroleum Technology Research Center at the University of Regina in Regina, Saskatchewan. They've got a variety of partners that are part of that program. Since 2015, over 400,000 tons have been injected into the Black Island and Deadwood formations. Those are deep saline formations. They showed you kind of at the bottom, towards the bottom of the sedimentary package in the Williston Basin at a depth of approximately 3.4 kilometers. The Aquastore project is the largest active field lab in the world for measurement and monitoring of CO2 storage in a deep saline formation. Moving on to some of the North Dakota projects. I'm going to start with a quick overview of what we call Project TUNDRA. Project TUNDRA is a project that is in the development stage, being managed and executed by Dakota Power Cooperative, which owns and operates the Milton R. Young coal-fired power plant, with coal being supplied by BNI Energy. And the concept there is to capture CO2 from the coal-fired power plant and inject it into a deep saline formation, actually a couple of different deep saline formations for CCS to take advantage of the 45Q tax credits that are available. A future paradigm for that project would be possibly to sell that CO2 to oil field operators for enhanced oil recovery in Western North Dakota. But that's sort of their visionary paradigm. That would be, a couple of decades out, most likely. To date, the Project TUNDRA program has generated data from 2 stratigraphic test wells that were drilled. Core was collected and analyzed. There was a 6 square mile seismic survey. Between the core analysis and the seismic survey, the Broom Creek and Deadwood formations were validated as good targets for CO2 storage that could handle the amount of CO2 that the coal-fired power plant would be generating. And between the baseline data that was collected, the models, the simulations, we worked with Dakota to put together a permit application package. And indeed, 2 CCS storage complex permits were granted by the North Dakota Department of Mineral Resources in 2021. There was one that was granted for the Deadwood Formation, and then another one that was granted for the Broom Creek Formation. And if this moves forward, that storage will be done in a stacked storage kind of setting. And then there's currently they're in the final stages of a FEED study for the capture plant. And Dakota Power is in the process of determining sort of the final economics and making a final decision on whether or not they're going to go forward with building the capture plant and doing the CCS project. But they do have the permits in hand. Moving on to the Red Trail Energy project. This is a project, I'll spend a little bit more time on this one because this one is actually, it actually came to fruition in terms of injection has begun. So I'll tell you folks sort of a little bit of a longer story about this one. So the Red Trail Energy plant is located near Richardton, North Dakota, in southwestern North Dakota. It's a corn-based biorefinery that processes about 23 million bushels of corn per year and produces about 64 million gallons of ethanol, and as well as a variety of co-products. And the folks at Red Trail, they decided to move forward to the CCS project in order to take advantage of both the 45Q tax credits and the California low carbon fuel standard tax credits. So they move forward with the CCS project. The capture that is located, it's been constructed, and it's a liquefaction system that takes the CO2 that's generated from the fermentation process and ultimately runs it through a scrubber and then through a liquefaction process where it's dehydrated and compressed and ultimately sent to the injection well for CO2 storage. This is an aerial photograph of the CO2 scrubber stack. So you see it's a fairly small footprint that you've got for an ethanol plant. You know, the CO2 that's coming off of a fermentation process is over 90% pure CO2, although it's at atmospheric pressure. So you've just got to do a little bit of dehydration. You've got to scrub it a bit and then compress it for CO2 storage. When we talk about the storage component of the Red Trail ethanol project, we're looking at the Broom Creek Formation as the target down here, Pennsylvania aged. The Broom Creek Formation regionally has a storage capacity of about 10 billion tons of CO2. The Red Trail Energy CCS project will generate about 3 million tons of CO2 over 20 years of the projected life of the project. And it's a sandstone. This is a piece of core here from the strat test well that was drilled. So the Broom Creek Formation is at a depth of about 6,400 feet, so a little over 2,000 meters underlying the Red Trail Energy plant. It's an aeolian dune deposit, Permian age. It's thickness of about 230 to 420 feet. So you know, around 100 meters average thickness, permeability of 320 millidarcies with an overlying confining zone of about 1,000 meters. This is an aerial image on the right, or I'm sorry, on the left. You've got a topographic map showing the location of the Red Trail Energy facility, located just a little ways east of the town of Richardton, North Dakota. And the yellow highlighted areas are the area that Red Trail Energy owns. And then the image to the right is a map view of the stabilized plume boundary in purple there. And then the storage facility area, the permitted area, is the white hash line around the stabilized plume boundary. Then you can see the hearing notification area. And this is we only need one injection well for this project. and then there is one monitoring well for the project. And you see here, we're looking at about 180,000 tons of CO2 per year. We've got the Class 6 permit approved, and they're ready to move forward. In fact, they have started moving forward. When we talk about CCS implementation, a lot of work was done to get this thing going. That's a picture of the wellhead. You see a picture of the seismic vibe trucks that were used to generate the original baseline seismic data. You've got a picture of the capture unit there, and the project timeline, just kind of give you a sense of everything that went into getting the Red Trail Energy project up and going. In 2019, they decided to take a look at sort of the pre-feasibility and feasibility data gathering. So they started off on their characterization and monitoring program by acquiring seismic data in the area. Based on the seismic data and what was known about the geology from offset log data, gave Red Trail a positive feeling about designing a well and starting the permit application process. So they started gathering near baseline data in the second quarter of 2019. They put out bids for a capture unit at the end of the second quarter of 2019. By the first quarter of 2020, they had the permit in hand to and a rig ready to go to drill what was the original appraisal well or a stratigraphic test well, captured, collected core, ran well logs, and that well was drilled and completed with the intention of it becoming the injection well once they got the permit. So that was drilled in the first quarter of 2020 with the core collected, tested, and some downhole baseline monitoring using that well and geophysical techniques was initiated in early 2020. In the fourth quarter of 2020, they got the capture system was contracted, and they also, based on what we learned from that first well, they made the decision to go ahead and move forward and drill a second monitoring well, which also provided us with more geologic data, which we were then able to incorporate into the model. Moving into 2021, the capture construction was initiated, and also the UIC Class 6 application was submitted to the North Dakota Department of Mineral Resources. All the data that we had generated in 2019 and 2020 went into developing that permit package. That permit package was, I believe it was about 600 pages of information that included all those different plans that I showed in that previous slide, as well as all of the different geologic exhibits and geologic data that was needed to demonstrate that the Broom Creek Formation was suitable for CO2 injection, and that the overlying Opeechee Formation was suitable as a seal for that injected CO2. From the time that the permit was submitted in the first quarter of 2021 until the fourth quarter, Red Trail went through a hearing process, and by the middle of the fourth quarter of 2021, their permit application was approved. So they had the permit in hand by the middle of the fourth quarter of 2021. Meanwhile, they were working on getting the capture facility constructed and ready. They were getting the baseline monitoring installed and operational. And all of that meant that by June of 2022, Red Trail Energy was able to start capturing that CO2 and injecting CO2 into the Broom Creek Formation. And in fact, the injection commenced on June 16th of 2022. The permitted average rate is about 500 tons per day, and the permitted maximum rate is 4,100 tons per day. This is constrained by bottom hole pressure. And you see some pictures there from the grand opening of the CCS project. So I also want to mention that outreach is an incredibly important part of getting the permits, getting the pore space access getting all the stakeholders to view CCS in a positive light and give their approval to moving forward. Red Trail Energy, I think, did a fantastic job of holding open houses. People from the public in the Richardton area could come in and they would have their questions addressed and answered by folks from the ERC, folks from other technical experts, folks from the North Dakota Department of Mineral Resources, so they could explain the regulatory framework and the pore access and the pore space ownership elements of it. Talked about the results of the geologic characterization. They developed a web page with frequently asked questions. Really got out and made sure that the project had some positive visibility in the community with frequent engagement and briefings to regulators and county and city commissioners. And then there were also informational videos and virtual Q&A sessions and a series of media materials releases over the course of those 3 years that this project was going through the process. If folks are interested in learning more about the Red Trail Energy CCS project, there's a YouTube video that kind of steps through a lot of these elements that I've talked about in more detail, and I'd encourage folks to check that out. One last CCS project in North Dakota that I'll talk about, and that is the Great Plains Synfuel plants. Lignite coal gasification plant is looking at doing a CCS project. Just for a little background on what the lignite coal gasification plant located near Beulah, North Dakota, in central North Dakota, that generates synthetic natural gas, CO2 for enhanced oil recovery that goes up to Weyburn. They also generate food and beverage grade liquid CO2 that they can load onto trucks. They generate liquid nitrogen and then krypton and xenon gases. They also develop anhydrous ammonia, urea, and other chemicals such as cryolic acid, naphtha, phenol, tar oil, hydrogen, and then fertilizers like ammonia sulfate and anhydrous ammonia. So a lot of products come off of the lignite coal gasification plant at Beulah. That plant is owned by the BASIN Electric Power Cooperative. It's operated by a subsidiary of BASIN Electric, Dakota Gasification Company. And then the DGC Great Plains CO2 sequestration project, Carbon Vault is a major partner in that, and Carbon Vault would be the ultimate operator of the CCS project that will be taking CO2 captured from that Dakota Gasification Company plant and injecting it into a deep saline formation. The Broom Creek Formation is the target for that one as well. They're looking at beginning storage, injection of CO2 into the Broom Creek sometime in 2023. They've got a permit to scale that injection from 1 to 2.7 million tons per year. They've got a permit for 26 million tons of storage in the Broom Creek over approximately a 12-year injection period. And what's kind of interesting about this project, at least in North Dakota, it's the first project to implement a pattern approach to optimizing storage and the project footprint. So to kind of summarize the permitted CCUS projects in North Dakota, I talked quite a bit about that Red Trail plant down in Stark County, North Dakota. The DGC, the Great Plains Synfuel Station plant project. You see the storage facility area and area of review for that one. And then you've got the Project Tundra, Minn Kota project at the Milton R. Young Station, and the permitted storage facility area and area of review for that one. Give you a sense of where these are located. Again, these are the projects that currently have permits to inject, with the Red Trail ethanol plant being the first one they actually started injection. And just to kind of wrap it up, it looks like I've got a few minutes here. I want to touch on some of the EOR opportunities in North Dakota and in the Williston Basin, and just to kind of give you folks a sense of the size of the prize for enhanced oil recovery in North Dakota. When we talk about the conventional fields, these are the legacy fields. Vast majority of these fields are in carbonate reservoirs of the Mission Canyon, Dupro, Lodgepole, and Red River formations. We've identified over 200 conventional oil fields in North Dakota that we believe are suitable for CO2 enhanced oil recovery. They would require about 358 million tons of CO2, which would produce over 1 billion barrels of incremental oil. As I mentioned, down there in the southwestern portion of North Dakota, Denbury Resources has already initiated enhanced oil recovery using CO2 from the from a couple of different gas processing plants in Wyoming that has been pipelined up to the Cedar Hills field in North Dakota. That project has just been initiated in the spring of 2022. But of course, in the Williston Basin and North Dakota in particular, it's the unconventional tight oil resources of the Bakken that are really where a vast majority of the activity are taking place, and it's got a size, a prize for conventional recovery, or I shouldn't say conventional recovery. What I mean is the primary recovery for the Bakken field using horizontal wells and hydraulic fracturing is about 6 to 8 billion barrels of oil over the course of the next couple of decades. But there's actually about anywhere, depending on which estimate you want to go with, there's anywhere from 300 billion to 600 billion barrels of oil in place in the Bakken and Three Forks formations. So there's a huge amount of oil being left behind after primary recovery. We've been working at the ERC to do a lot of research, working with a lot of operators. We've been involved in a couple of different CO2 EOR pilot tests in North Dakota and the Bakken. And I really do believe that the future of EOR in the Bakken is looking good. I think it's on a trajectory to sort of figure that out. And once industry figures out how to do enhanced oil recovery in these tight formations like the Bakken, what we're looking at in the Bakken is about 1.1 to 3.2 billion tons of CO2 could produce up to 3.2 to 7 billion barrels of incremental oil. Those are based on a study that we did, but was also another study that was done by Villakruska and his folks at ARI, published in 2020. And what was really interesting is we both kind of, we took different approaches to look at this, and we came up with very similar numbers. So so very, very big prize to be had for using CO2 enhanced oil recovery in the Williston Basin, and I think that's going to be a big part of the CCUS story as we move out another 10 or 20 years down the line. With that, I want to thank you for your attention and open it up to questions. Thank you.
Thank you very much, Jim.
Thank you, Jim. We made it finally. Yeah, and the first beginning, I mentioned SimTech is honored partner with PCOR since this spring, and really amazing because I believe there is maybe the major like a CO2 capture example maybe in PCOR this program. So based on this question and to this question, my question is, do you have like a roughly magnitude how much CO2 capture and use for CO2 EOR in WILLISTON or maybe other under PCOR? How much that is? Do you have a number like?
Oh yeah. I mean that's kind of where to go back to this one. You know, this is just in North Dakota. So we're looking at 358 million tons of CO2 necessary for enhanced oil recovery in the legacy conventional fields. And we came to that value using the information that comes out of the experience down in the Permian Basin in conventional fields, as well as information that's been generated by folks up in Canada with the Weyburn project. So, we're talking just in North Dakota, we're looking at 358 million tons of CO2 needed for EOR. If you look at other parts of the region, the Wyoming portion, where EOR is being contemplated, going up into Alberta, where they're doing, I mean, we're probably looking at, upwards of 1 billion tons of CO2 that's necessary to do enhanced oil recovery across the whole region. And that's just in the conventional fields.
Okay, thank you. See you.